Want to simplify data flow in SwiftUI? Learn how stacked data structures can streamline your app's navigation, undo action, and state management in just a few minutes. So the structure we'll be implementing will allow last in, first out functionality. So this is the app that we'll create. At the moment, David is the first person at the top of the stack. But if I want to add another person to the top of the stack, I can enter the person's name in the text field name field, enter the age, 20, then add the person. So now Andrew is at the top of the stack. If I want to filter or search for all the people in the stack, I just type in the search box, type a character, for example, E, click on the Find by Name button, and then it finds all the names of people that contains the letter E: Alice, Charlie, Andrew. So the next thing I'll show you how to do is to remove the person from the stack. Since Andrew is the first one on top of the stack, if I click on the Remove Top Person button, this person will be removed from the stack. Now David is the first person in the stack, and just to show that Andrew has been removed from the stack, I'll type in Andrew's name in the search button, and it doesn't exist, as you can see. So this is the app that we will create in this tutorial. The first thing we need to do is to create a new person struct. Select Swift file, name the file person, struct person, let name string, let age int. Next thing we need to do is to create our struct that's called stack. So we need to create a new file, Swift file, and name the file stack. Then type in the following: struct, public struct, stack, element, and the purpose of line 10 is to define a generic parameter allowing stacks to store any type of element. That's why we have the keyword element on lines 10. This flexibility enables the stack to hold a variety of data types such as string, integer, or custom types, our own objects. Private var storage element so that initializes an empty array to store the stack elements. Public init which is our default initializer to create a new instance of the stack. Public init element which is an array of elements. Storage is equal to elements. And the purpose of line 16 is an initializer to create a stack from an array of elements. Public mutating function push element storage append element. And the purpose of line 20 is to add an element to the top of the stack. At discardable results, public mutating func element, which can be optional, return storage, pop last. So lines 24 removes and returns the topmost element from the stack, and it returns nil if the stack is empty. Public func heap element return storage last. The purpose of line 29 is to return the topmost element without removing it from the stack. And then the next one we need to add is public bar is empty. Rule peak equals nil. The purpose of that method is to return true if the stack is empty. Otherwise, it returns false. The next thing we need to do is to add an extension to provide stack functionality that's specific to the person elements, so that we can filter and search by name. So we add this after line 38, make it a bit neater. Extension stack where element is equal to person. Function find by name that contains the name that we're trying to find, and then it will return a person, object, an array of people. Let's search name equals name dot lower case return storage filter $.0 name lowercase contains search name. So this ensures that it will work in any case that we type in, lowercase or uppercase. I'll just compile it. In the next tutorial, we will add the stack view model. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to simplify data flow in SwiftUI? Learn how stacked data structures can streamline your app's navigation, undo action, and state management in just a few minutes. So the structure we'll be implementing will allow last in, first out functionality. So this is the app that we will create. At the moment, David is the first person at the top of the stack. But if I want to add another person to the top of the stack, I can enter the person's name in the text field name field, enter the age, 20, then add the person. So now Andrew is at the top of the stack. If I want to filter or search for all the people in the stack, I just type in the search box, type a character, for example, E, click on the Find by Name button, and then it finds all the names of people that contains the letter E. Alice, Charlie, Andrew. So the next thing I'll show you how to do is to remove the person from the stack. Since Andrew is the first one on top of the stack, if I click on the Remove Top Person button, this person will be removed from the stack. Now David is the first person in the stack, and just to show that Andrew has been removed from the stack, I'll type in Andrew's name in the search button, and it doesn't exist, as you can see. So this is the app that we will create in this tutorial. In this tutorial, we will create our stack view model to manage the state of the stack and connect with the SwiftUI view. So the first thing we need to do is to create a new Swift file. Name the file stack view model. Import observation. At observable to enable the class to detect any changes within the view model. Var stack equals stack person The purpose of that line is to store a stack of person objects, and any changes will be observed by the SwiftUI view. Var new person name, var new person age, var search text, and the purpose for search text, or maybe I should name it something else, just call it find person by name. That's a better variable. So the purpose of find person by name is to enable the filtering. And then we need another variable called var search results that holds an array of person objects. Func setup initialize or initial data. So this is just temporary data for the stack, hard-coded data. Really, this should be coming from an API. Person name, Alice, age 30. Person name, Bob, age 40. Person name, Charlie, 50. And person name, David, age 60. The next thing we need to do is to create another function which is called push person. And the purpose of the push person function is to add another element, another object onto the stack. New person age, new person name is empty, return. So on line 34, if the age is invalid, if the age is not a number, and if the new person.name is empty, then it will just exit this function. But if everything is okay, then it will pass those values to the person object. to add that person onto the stack. And that should be stack dot push. Stack dot push. It seems like it cannot find our push method within our stack. So let's see what the problem is. Let's go to the stack. Stack.push. Oh, it's spelled incorrectly. On line 20 within the stack struct, it should be push. I'll just compile it to make sure it's okay. Next thing we need to do is declare the variables, declare the state of our variables, new person name and new person age. Set it to blank. And now we need to create the pop function, which is pop person. And the purpose of the pop person function is to remove an object from the stack, which removes the top object from the stack. And then to search our stack, we need to create a peak person function that enables our stack to be searched. So if a person is found in the stack that is similar to our criteria, then it will return that person as a person object using stack.peak. And then to check if our stack is empty, we need to use the boolean, which will return true or false if the stack is empty. And then to enable the user to filter the stack to find a person within the stack, we need to create a find by name function. Search results equals stack dot find by name. Search text. I'll just compile it. In the next tutorial, we will start to implement our content view. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to simplify data flow in SwiftUI? Learn how stacked data structures can streamline your app's navigation, undo action, and state management in just a few minutes. So the structure we'll be implementing will allow last in, first out functionality. So this is the app that we'll create. At the moment, David is the first person at the top of the stack. But if I want to add another person to the top of the stack, I can enter the person's name in the text field name field, enter the age, 20, and add the person. So now Andrew is at the top of the stack. If I want to filter or search for all the people in the stack, I just type in the search box, type a character, for example, E, click on the Find by Name button, and then it finds all the names of people that contains the letter E. Alice, Charlie, Andrew. So the next thing I'll show you how to do is to remove the person from the stack. Since Andrew is the first one on top of the stack, if I click on the Remove Top Person button, this person will be removed from the stack. Now David is the first person in the stack, and just to show that Andrew has been removed from the stack, I'll type in Andrew's name in the search button, and it doesn't exist, as you can see. So this is the app that we will create in this tutorial. In this tutorial, we'll start to add some of the GUI elements to the content view. The first variable we need to add is an @state private var, which is a new instance of the stack view model. We can delete line 15, add a navigation view, stack, The next thing we need to do is to add a text element. The purpose of this text element is to show which person is at the top of the stack at the moment. So it will show the person's name. Top person dot name. We missed out something. I need to do some unwrapping. So on line 17, add another B stack. And then we have to unwrap the view model. If let top person equals view model peak person. So we need to use the peak method to get the person that's at the top of the stack. And now we can display the name of the person that's at the top of the stack. Add some style to the font weight, dot semi bold, foreground color, primary, else, if there's nothing in the stack, then we display a message that the stack is empty. Stack is empty. Font title 2. Foreground color grey. After line 33, we have some padding, background, the color will be white, border radius 12, shadow, color, black, opacity 0.1, radius 8, x0 and y4. Padding dot horizontal, and then what do we need to do next? Yeah, we need to create another stack to enable the user to enter a new person. So this is the import section. Stack, spacing 15, stack, text name, foreground color, dot secondary, frame width 60, alignment dot leading. And then to enable the person to enter their name, we need to create a text field, enter name, text, The value will be bound to the view model dot new person name attribute dot padding dot corner background color system dot gray 6 dot corner radius 8. Next thing we need to do, copy our H-stack that we just created so that we can create a H-stack for the age to enable the user to enter the age of the person. So we just paste the H-stack code anywhere after line 50 and then change name to age. Enter age. Person. On line 45, that should be person name. Line 57, yeah, that's correct, new person age. And then for the keyboard type, it will be number pad. And everything else stays the same. I'll just compile it. In next week's tutorial, we will continue to add more GUI elements to our content view. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to simplify data flow in SwiftUI? Learn how stacked data structures can streamline your app's navigation, undo action, and state management in just a few minutes. So the structure we'll be implementing will allow last in, first out functionality. So this is the app that we'll create. At the moment, David is the first person at the top of the stack. But if I want to add another person to the top of the stack, I can enter the person's name in the text field name field, enter the age, 20, then add the person. So now Andrew is at the top of the stack. If I want to filter or search for all the people in the stack, I just type in the search box, type a character, for example, E, click on the Find by Name button, and then it finds all the names of people that contains the letter E. Alice, Charlie, Andrew. So the next thing I'll show you how to do is to remove the person from the stack. Since Andrew is the first one on top of the stack, if I click on the remove top person button, this person will be removed from the stack. Now David is the first person in the stack, and just to show that Andrew has been removed from the stack, I'll type in Andrew's name in the search button, and it doesn't exist, as you can see. So this is the app that we will create in this tutorial. In this part of the tutorial, we will add the buttons to enable objects to be added and removed from the stack. From line 64, add the following: dot padding, background, dot white, corner radius 12, shadow, color, color dot black, opacity 0.1, radius 8, x0, y4, padding dot horizontal, the next thing we need to add is another B stack. The purpose of our B stack is to add our buttons, action, view model, push person, so it pushes a new object onto the stack. For the button we need a caption, which is add person. Foreground color, dot white, font weight, semi, padding, frame, max width, infinity, that will ensure that all buttons are the same size. Backgrounds, linear gradients, gradient, and then we pass our colors that we want in our gradient. So this is our array of colors, which is color.blue, color.purple, And then we need a comma, start point, stop leading, end point, stop trailing. Dot corner radius, 10. Got padding, got horizontal, the next thing we need to do is to add our remove button. New model, dot pop person, text, remove top person. So I'll just copy what I just done previously between line 76 and 85. And then paste that after line 90. There's another bracket that we don't need, so we can delete the bracket on line 102. I'll just compile it now. On line 95, we just have to change the colors array. So instead of having blue, it should be red. Red. Instead of having purple, it should be orange. On line 101, we need to enter dot disabled. The model is empty. So what that means, if the view model is empty, then the remove top person button will be disabled. But when the view model isn't empty, then the button will be enabled. Dot opacity, view model dot is empty. So if it's empty, that means the opacity for the button will be 0.6, else it will be 1.0. So depending if it's empty or not, the view model, the button will be dimmed or not. After line 104, we need to add another V-stack. And the purpose of this V-stack is to enable the user to enter their search criteria that they want to filter the lists on. Dot foreground color, dot secondary, dot frame, width 60, alignment, leading, hex field. So this is where we enter our search criteria, name, and then what we enter will be down to the view model search text. Or search results. So that should be search text. So let's just refactor this. Or search results, yeah, that's okay. Is that right? Let me refactor it. No, that's wrong. It shouldn't be search results. It should be dot find. Let me go back into the view model. It should be find person by name because we're doing a filter. Find person by name. So that should be right. I'll just compile it. Yes, seems like that's right now. The next thing you need to do is to add some padding. Background, color, system, grey, 6, dot corner radius. Is 10. Let's make the corner radius 8 instead of 10. So I'll just save that. So in next week's tutorial, we will complete the content view for the GUI. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Want to simplify data flow in SwiftUI? Learn how stacked data structures can streamline your app's navigation, undo action, and state management in just a few minutes. So the structure we'll be implementing will allow last in, first out functionality. So this is the app that we will create. At the moment, David is the first person at the top of the stack. But if I want to add another person to the top of the stack, I can enter the person's name in the text field name field, enter the age, 20, then add the person. So now Andrew is at the top of the stack. If I want to filter or search for all the people in the stack, I just type in the search box, type a character, for example, E, click on the Find by Name button, and then it finds all the names of people that contains the letter E. Alice, Charlie, Andrew. So the next thing I'll show you how to do is to remove the person from the stack. Since Andrew is the first one on top of the stack, if I click on the Remove Top Person button, this person will be removed from the stack. Now David is the first person in the stack, and just to show that Andrew has been removed from the stack, I'll type in Andrew's name in the search button, and it doesn't exist, as you can see. So this is the app that we will create in this tutorial. In this part of the tutorial, we will create the Find by Name button and the list that includes the found names. On line 117, we will add our new button. Within Action Event, type in View Model, Find by Name, View Model, Search, Text, so that should be View Model, Find by Person Name. And then we need to create the caption for our button, Find by Name. Foreground color, but white. Font weight, semi-bold, dot padding, frame, max width, infinity, and for the background, we need to use a gradient, so I'll just copy the lines between 95 and 96 that we've done previously. Instead of having red, this color should be green. Instead of having orange, it should be blue. Corner radius is 10. Padding, horizontal, dot background, color, which is white, dot corner radius, 12, shadow, color, color, dot black, opacity 0.1, radius 8, x 0, y 4. Dot padding, horizontal, the next thing we need to do is to check to see if the view model isn't empty. So if the search results contains any values, then we need to loop through our view model search results array. And then we need another VStack. And then for the name, we just use the person object.name attribute dot font weight semi-bold text age person.age dot foreground color dot gray padding dot vertical 4 list style plain list style. On lines 140, really we shouldn't be using name as the unique identifier. We should be using a unique ID. Because the purpose of this tutorial is to show how stack data structure works. That's why I've done it this way, because the tutorial is not really about lists. But if you want to, you can fix the issue to do the list so that it uses a unique identifier instead of using the name. spacer, then just need some padding, top, background, color, system, grade 5, edges, ignore safe area, all. And for our navigation title, person stat manager, and then dot on a pair, and then set up our dummy data. Now just compile it. And now I'll just run it. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. In many real-world scenarios, like waiting in a line or service queue, it is important to process tasks or customers in the order they arrive. This is where the queue data structure comes in handy. A queue works on first in, first out principles, meaning that the first element added is the first one to be processed, just like the first person in the line is the first to be served. In this tutorial, we will create this app as seen on the screen, that allows the user to add and remove and search for people in the queue. For example, if I want to search the queue for names that contains LI, I just type in LI, and then all the names that contain the letter LI are filtered and displayed here. And then if I want to delete from the queue, I can just click on DQ button, the red button. At the moment, the queue has 4 names: Alice, Bob, Charlie, and David. So now I will delete from the queue. As you see, Alice was deleted. If I wanted to, I can now add a new person to the queue. I'll just add James, 30. To add a new person to the queue, I need to click on NQ, which is the green button. And as you can see, James was added to the end of the queue. And then if I want to peek to see who is the next person in the queue, for example, for an appointment to be seen, just click on the peek at front person button, the blue button, and then it should say or show Bob. Yeah, Bob is the next person to be seen in the queue. So now I would delete Bob from the queue. Just click on DQ to remove Bob from the queue. As you can see, Bob has been removed from the queue. And then if I click on the peek button again, it will be Charlie that is the next one to be seen within the queue. And this is the functionality we are creating in this tutorial. The first thing we need to do is to create a struct called person. Struct person identifiable let ID equals UUID, let name string, let age int. The next thing we need to do is to create a class called data, and this will populate our list and our queue. Class data static function create array of people in background. As you can see, we're using a completion handler. which will return an array, a person, and then the next thing we do is to simulate an asynchronous task using global dispatch queue, because really this should be coming from an API. And then we include a little delay in seconds, which will be about 2 seconds, 2.0. Dispatch queue, global, async after. So this queue will be executed after 2 seconds. Dot now, execute, or we can just do dot now plus delay in seconds. Let array of people and then we populate our person objects with name and ages. So we add the first object to the array, and then the second, the third, and then the last element we add to the array. And then we pass our array to our completion. Just compiling at the moment. In next week's tutorial, we will add our queue data structure to the application. Within your project, add a new Swift file. Name the file queue. This will be the queue data structure. type in the following: public struct q element and the purpose of that definition is to define a generic struct named q that can hold elements of type element. So it can hold an array of different types of elements. Private var storage element so that holds an array of elements within the queue. Public init, we just create our default public initializer, which is needed sometimes for creating an empty queue. So the next thing we need to do is to create another initializer to populate our queue. Element storage equals elements. So what that does is a public initializer that takes an array of elements and initializes the queue. Then we have to create a public mutating function enqueue element. So this mutating method's purpose is just to add items onto the queue. So we have to use storage dot append and pass the element. For example, the person's name and their age, that will be the element. The next method we need to create is our mutating function dequeue method. Elements. No, that should be element, not elements. So the purpose of the dequeue method is to remove items from the queue. So the first thing we have to check if the queue is empty. If storage dot is empty, return nil. Else return storage dot remove first. So it removes the first item at the top of the queue. The next method we need to create is our public function peak method that returns an element, which can be optional. Return storage dot first. So the purpose of the peak method is just to retrieve the next customer to be processed. That's within the queue. And then we're to create a computed property to check if the queue is empty or not. So this computed property will return a boolean if it's empty or not. And to enable the user to search the queue, we need to implement a find by name method, internal function find by name, which accepts a name, which is a string, and returns an array of people. Return storage dot compact map $.0, as person filter $.dot name contains name. So what we're doing there, we use compact map to filter and cast the elements to a person type, and then filter based on the name that the user typed in. In the next tutorial, we will implement our content view to use our queue data structure. We will now implement the content view to use the queue data structure. At state private var matching people So the purpose of that variable is to hold an array of matching people in our filter. That should be called person and not people. At state private var people, we create another array called people, and that is to populate our list. At state private var q equals q person we create and initialize an empty queue array. At state private var dq person, which is optional. At state private var new person name. So this will hold a new name for the person that we can enter to be stored within the queue. At state private var new person age string @state private bar search name string @state private bar show alert equals false, and @state private bar alert message. The next thing we need to do is delete lines 23 and then add a navigation view. VStack, and then a form. Within our form we have some sections. It's called all people. If people dot is empty, if the array is empty, display this message: no people in queue. We just add some style to the text element. Footnote. Foreground color grey. Else, that means it's not empty, so we can populate our list. Make sure each element within the list is unique by using .id. Person in. VStack. Alignment. Leading. Text. Person. Name. Font. Headline. Text. Age. Person. Age. Font. Subheadline. Missed out a bracket on lines 39. And another closing bracket. Just compile it. The next thing we need to do is to add a section to enable searching. So we add that section after lines 49. Section, header, text. Search people. VStack. Add a text element, search name, add a spacer, text field, enter name to search, and the name to search on will be the search name. Dot text field, text field style, rounded order text field style, auto capitalization, is none, dot frame, max width 200, dot on change, of search name, new value in, so on line 63 we need to create or call a method called search people by name. So I just add a comment here, search people by name, just add a to do, next thing we need to do is after line 67 we need to display all the matching people based on the search criteria, based on this variable, and then populate our list with all the matching people or all the matching names based on the search criteria. Matching people dot is empty, text, no matching people found, font dot footnote, foreground color gray, else populate our list with the matching search criteria. B-stack, alignment, leading, text person dot name dot font dot headline, text, age, person dot age, dot font dot subheadline. The next thing we need to do is add the input field to allow the person to add a new person, to allow the user to add a new person to the list or to the queue, so that the information can be repopulated on the list. So we do that after lines 93. Section header text, add a new person. So to add a new person, we need to create a B stack for our UI elements, H stack, text element that has the word name, and a spacer, and a text field to enable the user to enter the new name of the person that they want to add. New person name. And we do a similar thing for the age afterwards. Text field, style, rounded, border, text style, dot frame, max width 200, and we do the same thing for the age. So we just copy lines 97 to 104. And then we just paste it after lines 104 anywhere here. Update name to be age, enter age, new person's age, and for the max width, just make it 100. And then we just add a spacer to push the buttons to the bottom. So we'll be focusing on the buttons next week, next tutorial. And also adding the other methods that's needed for the content view. In this tutorial, we will continue with the content view to implement the buttons for NQ, DQ, PCAP front person, and other group operations that we need to do. So the first thing we need to do is to continue from line 119. We need to add our B stack, spacing, as each button will include 20 pixels of space. Button NQ, so we need to create our NQ person method. So let's just create that now. Create it anywhere after lines 129. Private function NQ person. And the purpose of the NQ function is to enable the user to add a new person to the queue. And this will include the person's name and the person's age. Equals int, so we convert the person's age to an int. Person name is empty. So if it's not empty, then we get the value, else we just exit. Now we have the value of the person's name. And their age. We then pass those values to the person constructor or initializer init method. New person name, age, and age. Q.NQ, new person. So we add the new person onto the queue. People.append new person. Add the new person onto the people's array. New person name equals comma comma. New person age equals comma comma. So now we can return to lines 125 and then call the end queue person method. We need to add a frame to the button to enable each of the buttons to be the same size using infinity. Padding, background, color is green, foreground, Color is white. Corner radius for curvy corners, which is 8. The next button we need to create is called DQ. And the purpose of the DQ button is to remove a person from the queue. So we need to create a new function which is called DQ, or DQ person. And let's create that function now. Private function or func DQ person. DQ person equals Q DQ. If let DQ person is equal to DQ person, so if it's not nil, if it includes a value, people dot remove all $ dot ID is equal to DQ person ID. So if the IDs are the same, then remove it from the array. That should be people, spelled incorrectly. Remove all, that should be. So what we need to do now is return to lines 133 and call our new method, which is DQ person. And we do what we've done previously to the button, so that each button they're the same size. Change the background color to red. The next button we need to create is peek at front person. Button peek at front person. So we need to create a new method called peak person. Private func peak person. If let peak person is equal to q dot peak, so what that means, if there's something in the queue that exists, so it's not nil, then we get that person. Alert message is equal peak at peak person dot name, age, peak person dot age. Else, if it was nil or empty, alert message equals the queue is empty. Show alerts equals true. So what we need to do is what we've done previously with the rest of the buttons, with other buttons that we created earlier. We have to assign the frame and infinity for the max width and the colors. So the background color will be blue and foreground color is white. Padding horizontal, (16), padding dot bottom 20. The next thing we need to do is to add a navigation title, queue operations, dot navigation bar title, display mode, inline, dot alert is presented, show alert, alert. So the overload that we need is the first overload. So that will be text, queue operations, operation, message, alert message. And for the dismiss button, we will just use the default with an OK. With OK for the caption. The final thing we need to do now is to populate our queue and our array using dots on a pair. Data dot create array for people. In background, people in. So within this closure, we'll be using dispatch queue.main dispatch queue.main async. On line 156, that should be in line and not line. Self.people equals people. So we initialize our people array, and now we will initialize our queue. Using a people array. Self.matching people equals self.queue.find by name, search name. And the purpose of that line is just a default search when loading the screen for the first time. Now I'll just compile it and run it to see if it works or not. As you can see, the application has now loaded. So if we want to add a new person to the queue, I'll just type in Fred 22 for the age. Click on End Queue. You can see Fred has been added to the end of the queue. If we want to remove someone from the queue, just click on End Queue, and then Alice will be removed from the queue because Alice is the first one in the queue. As you can see, Alice was removed. And we can also filter, so we can filter by name or few characters in the name. Type in Li. Xcode is a bit slow. Type in L. Lowercase Charlie. Type in I. locates Charlie and David, or E, Charlie and Fred, or a name that doesn't exist, it won't locate anything. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and Swift UI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. Within your Swift UI project, create a new file and name the file person. The next thing we need to do is to define our class, which is called person. Because the linked list will be interacting with person objects. Public var my ID, which is int. We also need an initializer, public init, name, string ID, int. And then we need to assign the name to the name property of the person class. Self.name equals name. Self.myID equals ID. The next thing we need to do is to create an extension. We just create that extension within the person class, but the person class is a very small file. Extension, person, identifiable. We need identifiable to loop through the values to populate the list. Public var ID int self.myID. And the purpose of lines 22 is to return the person's unique identifier. I'll just compile it. In the next tutorial, we will add the linked list nodes class. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and Swift UI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will implement our linked list nodes class. The purpose of the linked list node class is to provide a structure for the nodes to enable each node to store data and to connect the next nodes and enable traversing from the linked list in both directions. So the first thing we need to do is to create a Swift file. Name the file linked list node. Create our class that's called linked list node. Our class will be a generic class. The next thing we need to do is to create another variable, public var t, and this is the value stored in this node of a generic type of t. Type the following: public var next linked list t question mark. On line 14, we create a reference to the next node in the list, which is an optional linked list node of the same generic type. On lines 12, we need to move the colon closer to var. Oh, we missed out the variable name. That should be value. The next thing we need to do is to create a weak reference. Now type the following: public var weak previous linked list node. which is also a generic and optional. So on line 16, we create a weak reference to the previous node in the list to avoid a retain cycle. This is an optional variable. The next thing we need to do is to create our initializer, our init method, that will accept a generic and then we need to assign our generic value to our private variable value. Line 16, I think it's incorrect. Oh, it should be the other way around. So it should be public. Oh, that's right now. Public weak var previous. Just compile it. In the next tutorial, we will implement our linked list class. Please remember to like and subscribe. Thank you. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. In this tutorial, we will start to implement the linked list class to enable the user to add and remove generic objects from the linked list. The first thing we need to do is to create a new Swift file and name it linked list. Linked list. And then type in the following: public class linked list, open bracket T, colon, sequence. The linked list class conforms to the sequence protocol, and the purpose of that is to enable the class elements of the linked list to be looped within a list. The next thing we need to do is to create the first node in the linked list. Linked list node T, which will be a generic. And then we need to create another node, which is the last node, that's called tail. Private var tail linked list node T, which is also optional. We need to create a public init method, which is the default init, to create and initialize an empty linked list. The next thing we need to do is to create a computed property to detect when the linked list is empty. Now we need to create another function that's called public func append, and the purpose of this function is to enable generic objects to be added to the linked list. New node equals linked list node value, and that's the new object that we're passing in to the linked list node. And we need to check to see if the linked list tail is nil or not. So we do safe on wrapping. If there's a value in the node, then we get that node and assign it to the next node. And then we set the new node to the previous node of the current tail. And now we need to use an else statement. So if the list is empty, we assign the new node. We assign the head to the new node. And then now we need to update the tail to be the new node, since it is the last node in the list. And then the next thing we need to do is to enable searching within the linked list. And the purpose of this function will be to return the node at a specific index within the linked list. So we need to return a linked list node generic object, which can be optional. If index is more or equal to 0, that means we start from the head of the linked list. Var node equals head. Var I is equal to index. And the next thing we need to do is to traverse through the linked list as long as there are nodes, while let current node equals to node if I equals 0, return current node. I minus equals 1. Purpose of that is to decrease the counter by 1 for each node visited. The next thing we need to do is to move to the next node in the linked list. Current node.next. And then on line 57, or anywhere after line 57, we just type in return nil. I'll just compile it. Linked list does not conform to protocol sequence. The reason for that error is because we need to implement the iterator, but we'll implement those features in the next tutorial. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and Swift UI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will create the iterator struct. The purpose of the iterator struct is to loop over the linked list objects and to retrieve the next object within the linked list. So the first thing we need to do is to create our new struct. And then when we create the new struct, it should get rid of this error message that we're getting at the moment. So type the following: public struct iterator protocol. And we need to conform to the iterator protocol to enable the iteration within the linked list so that the linked list can retrieve the next element. Private bar current node linked list node, which is a generic. And the purpose of that variable is to store the current node that's been iterated over, starting with the head node. We also need our initializer, which is our init method. Start node linked list, which will accept a generic optional. Current node equals start node. The next thing we need to do is create a next function, which is mutating. And the purpose of the next function is to retrieve the next element in the iteration. We use defer to ensure we move to the next node after the current value has been returned. And then we just return the current value of that node. The next function we need to create is called make iterator. And the purpose of that function is to create an instance of the iterator. double it func, make iterator, return, iterator. So this creates and returns an iterator starting at the head of the linked list. Still not compiling. I think it could be there shouldn't be this bracket there. That bracket shouldn't be there. Let me try it again. Close the struct here on line 86. And then we continue from line 73. Missed out something. I forgot to declare the variable current node. Guard let current node equals current node, else return nil. So what that does, it will safely unwrap the current node if it's nil. If it's nil, I mean, there are no more elements to iterate over. Just compile it now. So that warning has now gone and it's now compiled, which is good. The next function we need to implement is called find by name. Find by name. And the purpose of this function, find by name, is to locate all the person's nodes that contains a specific string within that name. So this is the name that we're searching on. And then we will return an array of person, of people objects. The next thing we need to do is to create an empty array to store the matching results. Or the matching person object. And then now we have to start traversing the linked list from the head node. And then we also have to iterate over the linked list as long as there are nodes. That person equals node dot person dot value. If person dot name dot contains name dot lowercase. So if it's found, we add that object to the results array. And then we move to the next node within the list. Current node equals node dot next. And then we just return the result to the user or to the calling method routine. So now just compile it again. Yeah, it should be results, not result. Compile. In next week's tutorial, we will implement the linked list view model. And please remember to like, comment, and subscribe. Thank you for joining us. If you found this tutorial helpful, please comment, like, and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and Swift UI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will implement the linked list view model class. The purpose of the view model is to manage the state and logic of the linked list for a Swift UI view. The first thing we need to do is to create a new file, a Swift file. Name the file linked list view model. The next thing we need to do is to import SwiftUI. And then decorate our class with observable. Observable is not coming up. I must be using the wrong version of Xcode. So I just switch over to the correct version of Xcode. I just switched over to Xcode 15. At observable. Class. Linked list view model. So the purpose of using at observable is to enable the class to detect for any changes within the properties or the methods. And then the next thing we need to do is to create a new instance of the linked list object that will hold an array of person bar linked list equals linked list person. The next thing we need to do is to create a publish property to store the search text entered by the user. Bar search text. And to do that, we use didSet. And the didSet block will then trigger another function which will be called filtered people. Or filter people, as in filter search. So now we need to create that function, filter people. Func filter people if search text is empty. Filtered people equals array linked list. So what that does, if the search text is empty, convert the linked list to an array and assign it to the filtered people array. The filtered people variable doesn't exist as yet, so we need to declare that variable. Bar filtered people. So the filtered people will contain an array, a person array. And the next thing we need to do, so if there is something to filter by, then we need to filter the linked list. using the information that was provided in the search text variable. The next thing we need to do is to set up default data, set up initial data. So we add sample person object to the linked list, and this will include a name, an ID, linked list, append, person, name, Alice, ID, 1, and then we add another object to the linked list, which will be Bob, and the ID for Bob is 2, and another person to the linked list, or object to the linked list, is Charlie, ID 3, and then David. And then we also have to call filtered or filter people function. And the purpose of that is because the filter needs to be done immediately after populating the initial values within the linked list array, which is here. And then we need another function to enable the user to add a new object to the linked list. And this will be done using the Swift UI view. So just passing the parameters here. And then we add the object or the instance to the linked list. Linked list linked list dot append person name and ID. And because we have added a new person to the linked list, we need to call filter people again so that the linked list has the updated information, and then that updated information is then refreshed on the Swift UI view. I'll just compile it. In the next tutorial, we will implement the content view to enable the content view to call the methods within the linked list view model, and then the methods in the linked list view model will then call the linked list. So that's the tutorial for tomorrow. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and Swift UI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will start to add our GUI components to the content view to enable the user to interact with the linked list. Type in the following: @state private var view model equals linked list view model. @state private var new name. @state private var new ID. So the purpose of lines 13 and 14, when we create a new person, a new contact, we add a new name and a new ID to each of the records for that person. If you wanted to, we could convert this into a class, but at the moment we're using two separate variables to store the person's information. Stack spacing 20, text people linked list dot font large title dot font weight bold dot padding top dot foreground color blue. So what we've done there, we just created a little caption, a little title that will show the text people linked list at the top of the view. The next thing we need to do is to add our search and filter elements. H-stack, image, system name, magnifying glass, dot foreground, that's wrong, dot foreground color, gray, text field, search by name, view model, dot search, the view model needs a $sign at the beginning. $sign. The $sign's not coming up. Let me try it again. Dot text field style, which will be plain text field style. 10 to the padding, which is 10 pixels. Dot background color, system gray 6. Dot corner radius 6. No, corner radius is 10. Overlay, rounded rectangle, corner radius 10, stroke, and the color for the stroke will be blue, line width is 1. And then after line 35, we add some padding. Leading and trailing. The next thing we need to do is to add another B stack, but this time it is to enable the name of the person to be entered. And then, as we've done before, we also need a H stack to include a person built image. Dot foreground color, gray, text field, enter name, text, $, new name, padding is 10, background, color, system gray, 6, corner radius is 10, overlay, overlay, the same overlay that we created in the previous example. So I just copy and paste lines 33 to 34. Just compile it. In next week's tutorial, we will complete the content view. And if this tutorial has helped you, please comment, like, and subscribe. Thank you for joining us. If you found this tutorial helpful, please comment, like, and subscribe. See you next week. Struggling to understand linked lists? Dive into this beginner-friendly tutorial and master data structures in Swift and Swift UI today. This is the app feature that we'll be creating. The user is able to enter a new person to be stored within the list, and then enter an ID, add the person to the list, to the linked list. As you can see, my name and ID is displayed within the list. You can also filter or search for names within a linked list by typing Bob or B. It locates all the names that contains the letter B. If I type in E, it locates all the names that contains the letter E. So this is the tutorial we'll be creating. In this tutorial, we will add the Add Person button, the text field ID field, and the list to show all the objects in our linked list. So the first thing we need to do is, after line 50, add another H stack. The H stack includes a system image name, which is calendar. The foreground color is grey. We also add our text field to enable the user to enter their ID. And for the keyboard side, we will use number pads. Text field style will be plain. Background, color, system, gray, 6. Corner radius, 10. Overlay, rounded rectangle with a corner radius of 10. Stroke will be a blue color with a line width of 1. Our style shouldn't be there, it should just be dot blue. We have some padding. And trading, which is in an array. Oh, that should be dot leading. Next thing we need to do is to add our button to enable the user to add a new person. If let ID equals the int, so it will attempt to convert the ID as an int to an int, So what that does, if the ID can be converted to an int and the name is not empty, then using the view model, we add that new person onto the array with the name and ID. New name, blank, new ID, blank. On line 68, the I should be lowercase I. Let me check it first. Go to the definition. Yeah, that's correct. Yeah, it should be uppercase I. The next thing we need to do on line 74, we need to add our caption for our button, which is called add person dot font headline for the style, foreground color, white, padding, dot frame, max width, infinity, dot background, color is blue, corner radius 12, shadow. So we add a shadow to our button, color dot blue, dot opacity 0.3, radius 10, x0, y5. And then the next thing we need to do is to add a bit of padding. So just copy line 65. And now we just need to display the contents of our linked list using a for each loop within a list. Filter people, person in, vstack, alignment dot leading, spacing for, text, person dot name, on line 90, the vstack should have a bracket there at the end. It's got font, title 2, font weight, got bold, and then we display the ID for the person, which is person.id. Font, sub headline, Foreground color is grey. Add some vertical padding of 10 pixels. Set the list style to plain. And then set the background color to system gray 5. Opacity 0.1. Corner radius 15. Padding, and then we increment on a pair, and then call the view model set up initial data method to populate our list. I think we need another closing bracket after lines 109. See if that fixes it. I know what it is. On line 106, I missed out a closing bracket. And another closing bracket should be there. Still not compiling. And here's the application running. As you can see, we can filter or add a new person to the linked list. Seems like X code has crashed again. Try it again, add a new person. You can see the person has been added to the linked list. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.